So good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium. In this session, we are going to solve some PYQ on equilibrium constant Kc. Okay, let's start. So let us see, here is a question which is asked in 2023. Let us see that question. 4.5 moles each of hydrogen and iodine is heated in a sealed 10-liter vessel. In a 10-liter vessel. So there is a vessel, right? In this vessel, the volume of this vessel is 10 liters, right? In this 10-liter vessel, what are present? Hydrogen and iodine, H2 and I2 are present. At equilibrium, that means this reaction is reversible reaction. Products are formed. After the reaction has started, products are formed. What is the product? Hi. After the formation of the product, again, this product is undergoing backward reaction to form H2 and I2. After a certain time, equilibrium is obtained. That means when you are taking reactants, initially, what are the reactants? Hydrogen and iodine. There is no product, Hi. So, before reaction, that means at time t is equal to 0, 4.5 moles each of hydrogen. So, 4.5 moles. Here is also 4.5 moles of hydrogen and iodine is heated. At equilibrium, 3 moles of Hi were formed. The equilibrium constant for the given reaction. See, whenever questions are asked on equilibrium concept, we have to see for which reaction. For this reaction, Kc is asked. That reaction only we have written here. Why we are specifically mentioning that? Because equilibrium can be obtained from reactant side as well as from product side. By taking what reactants, equilibrium has been obtained. That is also very important point. So, we have to carefully look into the question and see for which reaction Kc is asked. Here, clearly, the reactants are H2 and I2 and the product is Hi for the forward reaction. For this given reaction, we need to calculate equilibrium constant. So this point you need to remember. Everyone has to remember. Okay. So at initially, there are only hydrogen and iodine, each 4.5 moles in this 10-liter vessel. So this has reacted and the product is formed. And after the formation of product, again reactants are formed. So after a specific or after a certain time, this reaction has attained equilibrium. At equilibrium, you are finding 3 moles of Hi. How many moles of Hi are given at equilibrium? So initially there is no Hi. So at time t is equal to equilibrium. It is found that 3 moles of Hi were formed. Right? Now let us see, from the given reaction stoichiometric equation, we know that 1 mole of H2 and 1 mole of I2 on reacting gives you 2 moles of HI. Okay. When 1 mole of hydrogen reacts and 1 mole of iodine reacts, 2 moles of HI are formed. When you compare the stoichiometric coefficient 2 with 3, then what will be 1? 1 will be 1.5. What is that? 1.5. So how much? See, 2 moles of HI are formed. 2 moles is equal to, see, from the stoichiometric equation, stoichiometric coefficient for HI is 2. When 2 is equal to 3 moles, when what will be 1? 1 will be 1.5. So how much, see, when 1 mole of hydrogen is reacted, 2 moles of HI are formed. 2 is equated to 3 moles, then what will be 1? 1.5. Okay. So then what you get? At time t is equal to equilibrium, initially 4.5 moles are there. How much is completed? 1.5 moles. How much is reacted? 1.5. How did we find that it is 1.5? Because it is 3. Okay, stoichiometric coefficient for HI is 2. 2 is given as 3 moles. Then what will be 1? 1 will be 1.5. The same is with the iodine also. That means 4.5 minus 1.5. How much is remaining? 4.5 minus 1.5 gives you 3 moles. Here it is also 4.5 minus 1.5 gives you 3 moles. So the number of moles of hydrogen at equilibrium 3 moles, the number of moles of iodine at equilibrium 3 moles, the number of moles of HI at equilibrium is 3 moles. Okay. Now let us write Kc for the given equation. Kc is equal to HI concentration power 2 by concentration of H2 and concentration of I2. Product concentration by reactant concentration. HI is 3 moles. It is present in how much volume container? 10 liters. So the volume of the container, because here we are speaking about the concentration. So 3 moles by 10 liters square by H2. So what are these concentrations? H2, I2, these are the concentrations of the reactants and products at equilibrium. At equilibrium, we have seen the number of moles. So 3 moles by 10 liter into 3 moles by 10 liter. So Kc, what will you get Kc? Kc will be equal to 1, right? Kc will be equal to 1. On substitution, you will get it equal to 1. Okay. And in another way, let us solve the problem. Let us take H2 plus I2 gives rise to 2HI at time t is equal to 0, 4.5 moles, 4.5 moles, 0, time t is equal to equilibrium. Let x be the number of moles of H2 reacted. Let x be the number of moles of I2 reacted. So 4.5 minus x, 4.5 minus x, So when 1 mole is reacted, hydrogen, and iodine 1 mole is reacted, 2 moles of HI are formed. This will be 2x. From the question, number of moles of HI formed. HI formed is equal to how many? 3 moles. That means 2x is equal to 3. Then what will be x? X is equal to 3 by 2, that is equal to 1.5 moles. 1.5 moles. So what is x here? Let us take x as number of moles of hydrogen reacted. If 1 mole of hydrogen is reacting, 1 mole of iodine reacts, and 1 mole of, or 2 moles of HI will be formed according to stoichiometric equation. Okay. Then Kc is equal to, how to write Kc? HI concentration power 2 by H2 concentration into I2 concentration, that is equal to HI concentration. X we have already calculated. 2x is equal to 3 by 10 moles per liter square by 3 by 10 moles per liter, because here 4.5 minus x is equal to 1.5. Already we have calculated. 4.5 minus 1.5 gives you what? 4.5 minus 1.5 gives you 3. In the same way, 3 moles per liter. You are getting one. So you can calculate it by taking x, or directly, if you are aware of this correlation between stoichiometric coefficient and the number of moles, then you can also calculate it in this way. Okay. Next question. It's given in 2016. The equilibrium constant at 298 Kelvin for the reaction A plus B gives rise to C plus D is 100. If the initial concentration of all the 4 species were 1 molar each. Okay. So for which reaction the question is asked, that you have to take into context. What is that reaction? A plus B gives rise to C plus D. Why we are specifically mentioning this? Because it is reversible reaction. Equilibrium can be obtained from either the product side or reactant side. So that is the reason why specifically we are mentioning this point. You have to take the reaction given. For the reaction given, you have to calculate. Okay. Now, at time t is equal to 0, that means reaction has not yet started. If the initial concentration means at time t is equal to 0. All the 4 species were 1 molar each. So 1 molar, 1 molar, 1 molar, and 1 molar. So let us consider that this is all happening in a container of volume is equal to 1 liter. Okay. So 1 molar means here, if it is volume 1 liter, then what will be number of moles? 1 mole. 1 mole per liter is equal to 1 molar concentration. Okay. So let us consider this is happening in 1 liter. This reaction is completely happening in 1 liter container. So 1 mole, 1 mole, 1 mole, 1 mole. 4 are 1 mole. At time t is equal to equilibrium, let us say, let the number of moles of A reacted is equal to X. Okay, at time T is equal to equilibrium, T equilibrium, X mole is reacted, then the concentration of concentration of A reacted will be equal to X moles by 1 liter. That is equal to X capital M. Okay. So I can write it as 1 minus X. If 1 mole of A is reacting, the same 1 mole of B reacts. So if X mole of A is reacting, how much B will be reacting? That is also X. If 1 mole of A is reacted and 1 mole of B is reacted, how many moles of C is formed? 1 mole and 1 mole. That means how much C is formed? C formed will be also X. D formed will be X. Already how much is there? 1. So 1 plus X. Already D initially present is 1 molar. 1 plus X. Okay. So what are these? These are concentrations. Concentration of A at equilibrium is 1 minus X. Concentration of B at equilibrium is 1 minus X. The same way concentration of C at equilibrium is 1 plus X and concentration of D at equilibrium is 1 plus X. Okay. Then let us write Kc now. Kc is equal to concentration of C into concentration of D by concentration of A into concentration of B. Okay. Equilibrium constant Kc already given. How much? 100. So 100 is equal to concentration of C 1 plus X, concentration of D 1 plus X, and concentration of A 1 minus X, concentration of B 1 minus X. Then what you can write? 100 is equal to, okay, 1 plus X square by 1 minus X square. Rooting on both sides. Okay. Square root on both sides. Then what do you get? 10 is equal to 1 plus X by 1 minus X. Then what you can write? 10 minus 10x is equal to 1 plus X. So 10 minus 1 is equal to X plus 10x. 11x is equal to 9. X is equal to 9 by 11. Okay. So if you calculate 9 by 11, what do you get? You will get it as 0.818. So what you got? X. The value of X. As we got the value of X, then what is asked in the question? Then equilibrium concentration of D. So concentration of D at equilibrium is how much? Is how much? 1 plus X. How much it is? 1 plus X. So 1 plus X is 1 plus X. We have calculated it as 0.818. That is equal to 1.818. 1.818. So what is the answer? Answer is 1.818. Understood? So let us go with the next question. Here is the question which is asked in 2020. What is that question? For the given reaction. What is the reaction given? This reaction. For this reaction, we have to calculate. So first of all, let us write the equation. What is that equation? given equation is x plus y is equal to 2z for this equation. Okay, 1 mole of x, 1.5 mole of y and 0.5 mole of z were taken in a 1 liter vessel and allowed to react. See, let us take this is 1 liter vessel. Volume is equal to 1 liter. Okay. At equilibrium, the concentration of Z was 1.0 moles per liter. Okay. The equilibrium constant for the reaction is x by 15. The value of x is. This is the question. Okay. At time t is equal to 0 initially, how many moles of x are taken? 1 mole. How many moles of y are taken? 1.5 mole. How many moles of z are taken? 0.5. This is all happening in 1 liter container. Okay. Then at equilibrium, let us consider that let x be the number of moles of x reacted at equilibrium. At equilibrium, how many number of moles of otherwise as there is x in the question already as the reactant, let it be alpha. Let alpha be the number of moles of x reacted at equilibrium. How much will be remained? So otherwise reacted, let us take reacted. X reacted is taken as alpha. Here 1 mole, 1 mole. So Y reacted will also be alpha. Formed. This is all okay. Formed will be 1 mole of X on reaction gives you 2 moles of Z. Alpha moles of X on reaction gives you how many moles of Z? 2 into alpha. So at equilibrium, at time is equal to equilibrium, what will be the number of moles of X? Already initially there is 1 mole. How much reacted? 1 alpha. So remained is 1 minus alpha. Initially there is 1 mole, reacted is half, the remained is 1 minus alpha. Initially, how much there? 0.25 moles, right? Here 1.5 is there now. How much is there? 1.5. So 1.5 minus alpha. This one 0.5. Already 0.5 is there. How much is formed? 2 alpha is formed. 2 alpha. Okay. So initially taken x 1 mole, reacted alpha, reacted number of moles alpha, remaining is 1 minus alpha moles. Initially there is y number of initially 1.5 moles y is present, reacted is alpha, remaining is 1.5 minus alpha. Initially present 0.5 moles, formed is 2 alpha. At equilibrium, the number of moles present, the number of moles of Z present is 0.5 plus 2 alpha. Right? So this is all happening in 1 liter container. Then if you write what is asked, equilibrium constant is asked. At equilibrium, the concentration of Z was found to be, what is that? 1 mole. So this is the concentration of Z at equilibrium. This is given as from the question. From question given, what is given? 0.5 plus 2 alpha is equal to 1. Okay. Then what I can write? 2 alpha is equal to 1 minus 0.5. Right? So 2 alpha is equal to 0.5. Alpha is equal to 0.25. Okay. 0.25. So at equilibrium, concentration of X is equal to 1 minus alpha. So 1 minus alpha moles by 1 liter. That is equal to 1 minus 0.25 moles per liter. Concentration of Y is equal to 1.5 minus alpha moles by 1 liter. That is equal to 1.5 minus 0.25 molar, which is equal to 1.25 molar. Okay. Then let's continue here. Let us continue here, or otherwise continue. Concentration of Z. Concentration of Z is equal to how much? 0.5 plus 2 alpha. Okay, already given it as 1. It is 1 molar. 1 mole per 1 liter, that is equal to 1 molar. So what is asked from here? What is asked? Kc. So Kc for this reaction can be calculated as Z, concentration of product, power 2 by concentration of X into concentration of Y. Concentration of Z 1 molar, 1 square by concentration of X is equal to how much? 1 minus 0.25, that is equal to 0.75 molar. So 0.75, okay, into Y is 1.25, 1.2. So Kc will be 1 by, right, 0.75 into 1.25. So this will be approximately 1.06. So Kc is given in the format of X by 15. How much did you calculate? This is equal to 1.06. Then X is equal to 15 into 1.06 approximately gives you 16. So the answer will be X. X is equal to how much? Here X is equal to how much? 16. Okay. So that's the procedure to calculate. Okay. Let us see. Let us solve the next question. This is the question. For the given reaction, what is the reaction? PCl5 gives you PCl3 plus Cl2. Cl2. So first of all, let us write the question. Let us write the reaction. PCl5 gives you PCl3 plus Cl2. For this already Kc is given. At time t is equal to 0. 3 moles of PCl5 is introduced in a 1 liter closed reaction vessel at 380 Kelvin. The number of moles of PCl5 at equilibrium is. So this is all happening in how much volume container? Volume is equal to 1 liter container, because when we are calculating Kc, concentrations of reactants and concentration of products are considered. In calculating the concentration, volume is necessary. Okay. Initially at time t is equal to 0, how many moles of PCl5 are taken? 3 moles of PCl5 are taken. These are introduced into a vessel so that PCl5 dissociates into PCl3 and Cl2, and as it is a closed container, again PCl3 and Cl2 combine to form PCl5. After a certain time, what happens is a chemical equilibrium establishes. Okay, so let us consider that let X be the number of moles of PCl5 reacted at equilibrium. Okay, at equilibrium. So you can write reacted. How much is reacted? X moles. Formed. Who is formed? Initially there are no PCl3, no Cl2. When 1 mole of PCl5 reacts, 1 mole of PCl3, 1 mole of Cl2 are formed. So if 1 is equal to X, then what will be 1 here? PCl3, X moles. Cl2 will also be X moles, right? So at time t is equal to equilibrium, what will be the number of moles of PCl5, PCl3 and Cl2? Here initially there are 3 moles. X moles were reacted, and how many number of moles remains at equilibrium PCl5? 3 minus X. Okay. Here PCl3 is X moles and Cl2 is also X moles. And everything is happening in 1 liter container. And we know that how will you write Kc for this reaction? PCl3 concentration into Cl2 concentration by PCl5 concentration, that is equal to X moles by 1 liter, X moles by 1 liter into X mole by 1 liter by 3 minus X moles by 1 liter, right? So Kc given 1.844. So Kc is equal to 1.844 is equal to X into X, X square by 3 minus X. 3 minus X. So then I can write that X square is equal to 1.844 into 3 minus X. So X square is equal to, right, 3 fours 12, 3 fours 12, 113, 8 3 is 24, 125, 3 ones 3 plus 2 5, 5.532, 12, 113, 24, 125, 5.532 minus 1.844x, right? Now I can write this as X square plus, this comes that side, then what do you get? 1.844 x minus 5.532 is equal to 0, right? Now it is in the form of a quadratic equation, like ax square plus bx plus c is equal to 0. Okay, if you want to find x, then formula for finding x is equal to minus b plus or minus root b square minus 4ac by 2a. Here minus b is 1.844, so minus 1.844 plus or minus b square So 1.844 square minus 4 into A is equal to 1. A is equal to 1 here, right? From this equation, what you can write? So A is equal to 1, C is equal to 5.532 by 2 into A. 2 into A is 1 again. So on substituting this, what do you get? On substituting this, what do you get? Okay. So X will be 1.6. X will be 1.6. So 1.6, right? So then what is the question asked? The question asked is calculate the number of moles of PCl5 in 10 power minus 3. 10 power minus 3. So at equilibrium, moles of PCl5 at equilibrium. This is the question asked, right? Is how much number of PCl5? PCl5 is 3 minus X. So 3 minus X. We have calculated X as 1.6. So 3 minus 1.6. 3 minus 1.6. Then that is equal to 1.4. But the question asked is in the format of 10 power minus 3. So this 1.4 can be written as 1.4 1400 into 10 power minus 3. So what will be answer? Answer will be 1400. Answer will be what? 1400. Okay. Let us see the next question. So this question is asked in 2022. What is the question? 2 NOCl gives rise to 2 NO plus Cl2. This reaction. For this reaction, we have to solve the given question. What is the given question? In an experiment, 2 moles of NOCl was placed in a 1 liter flask. Again, everything is happening in 1 liter container. Volume is equal to 1 liter. And the concentration of NO after equilibrium was established was found to be 0.4 moles per liter. The equilibrium constant, again asked equilibrium constant. So let us go with the equation. Given equation 2 NOCl gives rise to 2 NO plus Cl2. Right? At time t is equal to 0, how many moles of NaCl was taken? 2 moles. Okay. Initially, there is no NO and there is no Cl2. Now I am considering let 2x moles of NOCl reacted at equilibrium. At equilibrium, right? 2x moles are reacted. From the given equation, stoichiometric equation, 2 moles of NOCl on reacting gives you 2 moles of NO and 1 mole of Cl2 are produced. Okay. So reacted, let us take reacted is 2x moles formed. If 2 ratio, you see ratio, according to that ratio we have to write. If 2 moles of NOCl reacted, 2 moles of NO are formed. So 2x, so how many formed? 2x moles, and this will be x mole, right? at the time equilibrium, how many number of moles of NaCl are present? Initially there are 2 moles. So 2 minus 2x. Here this will be 2x moles. This will be x moles. These are all moles. Right? So in the question, at equilibrium, the concentration of NO after equilibrium was established is found to be 0.4 NO. So this is NO. So from the given question, we can write that 2x is equal to 0.4 molar. Then x is equal to how much? 0.4 by 2, that is equal to 0.2 molar. Okay, so what is asked? Equilibrium constant. So equilibrium constant Kc can be written for this reaction as NO concentration power 2 Cl2 concentration by NOCl concentration power 2. Right? So NO concentration is 2x. X we have calculated it as 0.2. That means I can write it as 0.4 square. This is all happening in 1 liter container. Okay. By 1 liter, number of moles by 1 liter. By 1 liter gives you concentration. Okay. Or otherwise, if you write by 1 liter, again you get it cancelled, right? So 0.4 moles by liter whole square into chlorine XX we have calculated 0.2 mole per liter by NOCl 2 minus 2x. So concentration of NOCl at equilibrium, that is equal to 2 minus 2x, that is equal to 2 minus 2 into 0.2, that is equal to 2 minus 2 into 0.2, 0.4, that is equal to how much you get? 1.6. Okay. So on calculating 1.6 moles per liter square, right? Then what do you get? Kc is equal to 0.4 square into 0.2 by 1.6 square. Then on calculating this, what do you get? 0.0125, right? So this can be written as 125 into 10 power minus 4. 125 into 10 power minus 4. So the question asked is dash into 10 power minus 4. See, the equilibrium constant at 30 degrees centigrade is dash into 10 power minus 4. So what will be the answer? 125 into 10 power minus 4. Okay. So first of all, you have to read the question carefully. For which reaction the question is being asked, you have to check that reaction. Then we have to solve the problem. To solve the problem, first of all, we have to read the question properly and understand the question properly. Without understanding the question, you cannot. So until you understand the question, you need to read the question properly, carefully. And when coming to physical chemistry, we have to first of all write what is given and what is asked and what is the concept related to it. If there is any formula related to it, we have to check it and carefully we need to solve. Okay, hope so you understood problems which are given in previous JEE mains. In the next session, we shall discuss about PYQ on Kp, equilibrium constant with respect to pressure of reactants and products at equilibrium. Okay, we shall meet in the next class. Thanks for watching.